Okay, we're going to take a look at how to read the periodic table.
Like top to bottom, left to right?
No, the periodic table is actually read. We're talking about looking at the individual symbols and being able to discern what information that you can get from an individual symbol on the periodic table, because there's a lot of information.
Okay. What
common.
information is in the periodic table? What do all those numbers mean? Those numbers actually tell you a lot about the identity of all the different particles and how many there are inside the atom. Because the atom, you probably have heard, is made up of 3 different particles: protons, neutrons, and electrons. So we've got a little chart here. We want to know...
Protons and neutrons in the nucleus, of course.
Yep.
Electrons on the outside. Sorry.
Yeah, we'll get there.
Oh, man.
We'll get there. Let's just do the
excited.
location then.
Okay.
Where are they? Protons and neutrons are in the nucleus. And you can see them down there. In the middle, the blue and red circles. And then on the outside, in orbitals, are the electrons. And if you look at those, you can almost see their masses. You can see, at least relatively, if you know where they are. The nucleus is bigger. Protons and neutrons are in the nucleus. Electrons are a lot smaller. That is reflected in their masses. Protons and neutrons have a mass of 1. We give it a new unit. It's called an AMU, atomic mass unit. It's just a unit for protons and neutrons.
Basically just made up by chemists to measure what we need to measure.
Pretty much. And electrons, they weigh 1 out of 1,800. So essentially, compared to a neutron, why don't we just call that a 0?
Yeah.
If you want to put 0 in there, they're so small, electrons weigh almost nothing.
Yeah, so most of the mass of an atom then comes from the protons and the neutrons.
Protons and neutrons, which we'll talk about later.
A minuscule amount from
electrons weigh nothing. But they are very important in the atom because they have a charge. Electrons, electricity, negative. Electrons are negative. They're on the outside of the nucleus. Neutrons, neutral. Neutrons, neutral, neutral, 0. 0 is neutral. Protons, positive. P and P, protons are positive, positive 1.
I just want to know why they weren't called negatrons.
Oh, that would be so much easier as far as teaching goes, but electrons are negative. The other two make sense. Positive protons, neutral, 0.
Although electrons, electricity, I guess.
Yeah, it works.
I guess someone was thinking at some point.
Basic information, we're going to use that and apply it to figure out different things about the atom. For instance, we are going to figure out the number of protons in an atom. How do we know that? Well, you look at the atomic number. Why don't we highlight that?
Hey.
Or we could just move it around a little bit on the screen.
Yeah, let's get the highlighter out. Oh, that's the wrong one.
There we go. Atomic number is the number of protons. It is the single digit that the periodic table is arranged by. You'll notice that they're all whole number integers of 1, and they go from 1 to about 115 or so.
That's because if that atomic number is a count of the protons, we cannot possibly have a half of a proton. It's either that element has 6 protons or it has 7 protons, and if you go from having 6 protons to 7 protons, then you have changed the element identity.
Change the element. So this is probably the most important fact to know about the periodic table. The number of protons tell you what the element is, and they will never, ever, 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 I'm not sure I have enough evers memorized, they will never, ever change.
What that means is that if I find a carbon atom here on Earth, it will have 6 protons.
6 protons. If you go back to when the Big Bang was created or started,
yes,
there were carbon atoms there. They had 6 protons. Never changes. So anywhere in the universe, 6 protons. If you have 7 protons, look at your periodic table, you have nitrogen. Something new, okay? Potassium is number 19. Guess what that means?
19 protons.
19 protons. Potassium will always have 19 protons. Very simple, but it can get confusing later on. That's the solid number, never changes. What does sometimes change are neutrons. But that's not the number of neutrons.
Nope, indeed it's not.
Not
That's
directly.
called the average atomic mass.
Which we will use to find the neutrons. So that is the second number. The protons is 1, atomic mass is the other. Those are the two numbers on the periodic table.
So we talked about this earlier, that the atomic mass is generally only from, I shouldn't even say generally, the atomic mass comes from the number of protons and the number of neutrons in the nucleus of an atom. Well, if the protons have to be a whole number, then why is that average, or is that atomic mass number not whole as well? Because protons and neutrons, you can't have like a half of each or anything like that.
Well, it's an average. Sometimes if you take 3 and 4, two whole numbers, you average them together, you get 3.5. In the universe, not every little sodium atom, for instance, has the same number of neutrons.
So this particular one has 12, but another one could have, say, 13. Okay.
So here's how we're going to figure out how many protons there are. We're going to take that mass.
I mean neutrons.
Yes.
Right.
Protons is the atomic number.
Right.
Silly.
Yeah, we know how to do that.
Neutrons. You take that mass, 22.99, and we're going to round it up, and we're just going to say it's got 23. Okay? It has a mass of 23. And we've got this little equation here. The mass, remember, is protons and neutrons. Electrons don't weigh anything. So that second number is only coming from the protons and neutrons. Well, 11 protons. That's the atomic number. That'll never change. Therefore, we can calculate the neutrons. 12 in this case, based on that mass. So we're just kind of taking the average and figuring out, rounding it, and then figuring out how many neutrons the element has.
So basically, we can use that average to figure out how many, the most common isotope is what it's called, in the universe of sodium has.
So most of the sodium atoms in the universe, since 22.99 is close to 23, most of them will have a mass of 23 and 12 neutrons. But that's kind of what we're doing with that number. We can also practice that. So how many neutrons are in these? Sodium we just did, 22.99, we'll round up to 23. Subtract 11 protons, or the mass is protons plus neutrons. Neutrons equals...
Setting up
we
the
are in
algebra
high
for
school.
you.
You can use an X instead of a question mark. And it doesn't equal 23. Okay, 23 minus 11.
Yeah.
You are doing it right.
Right.
12.
So, question mark. Oh, that's a 2.
This is ridiculous.
This is crazy. And 12.
12 it is.
Nice.
Potassium.
I'm not going to do that for the next couple ones. So
Potassium.
bear with us.
39.09. So it has a mass of 39. And that it comes from the protons and neutrons. So 19 protons plus, we'll say N, maybe?
Nice.
Neutrons.
Using a variable.
And that's how many neutrons, if you solve that brain buster, you get 20 neutrons. Boron, 10.8. Rounds up to 11. That's protons plus neutrons. Protons, of course, is the second number. Neutrons equals 6. Okay, put your calculators away for the next one if you need them. Electrons. These are the other ones. Now, the charge, they don't have any mass, but they do have a charge. The charge is important. Think about it for a second. Protons are positive, electrons are negative. Atoms can be neutral. What does neutral mean?
Neutral means that they don't have a charge. So
But
they're
they do
not
have
positive
charges.
or negative.
They do have charges, right? We just said positive and negative.
Well, if they balance each other out,
Oh, okay.
then
So
we neutralize the charges.
oh, it has to do with how many of each one you have. So let's say
Yes.
I had a positive one and a negative one. That's neutral, right?
Wait, let me do the math real quick. +1 plus -1.
Positive 1
Equals-
plus negative 1 equals 0.
Yeah, that seems to work
It's
out.
neutral.
Yeah,
Okay.
Okay.
So sodium, let's just
I'll buy that.
let's continue that logic. Sodium has 11 protons. Okay?
Mm-hmm.
And it has 11 electrons
So those are a -11.
because they're
Right.
negatively charged. You're not subtracting 11, but there are 11 electrons. That's
Okay.
going to be neutral. Okay? So the protons and the electrons are the same.
So yeah, that means if the atom is neutral, protons is equal to the number of electrons, and I'm going to use E minus to
'Cause they're
symbolize
negative.
the electrons because they're negatively charged.
Okay?
Right.
That one's easy. The tricky part comes when they are not equal. There is a net charge, and we call those ions. They're atoms with a charge, positive or negative. If you have more protons, the ion will be positive. If you have more electrons, it'll be negative. Remember, the protons will never change, okay? Never add or subtract those. The electrons can be added or taken away. So you're always trying to figure out how many electrons. Are you going to add them to make it negative, or are you going to take them away to make the atom positive? Always moving electrons.
So if you're a mathematical thinker, the charge is equal to the protons minus the electrons. So if those two numbers are the same, the charge obviously is 0. It's a neutral atom. If they are different, then you get either a positive charge or a negative charge, depending on how the electrons have changed.
All right. So we've got two different types of ions. Cations are positive, and they lose electrons. So if you take electrons away, you have more protons and they're positive. Magnesium, there's a neutral atom. Magnesium is number 12 on the periodic table. 12 protons and 12 electrons means it's neutral. If I take some electrons away, let's take 2 away.
So we've gone from having 12 electrons down to 10 electrons.
And that's a difference of 2. Now I've got 12 positives and 10 negatives. So my symbol here is going to be positive 2. We'll highlight that for you, or circle it. Magnesium, positive 2. It has 2 extra positive charges. That's a cation. The opposite is an anion. It is a negative ion. That's a vocab word there, anion. And when you add electrons, to get negative, you're going to add more electrons. They gain it. Chlorine, number 17, means it has 17 protons, 17 electrons. Let's say we added 1. Now we have...
So we're adding an extra electron. Now we have 18 electrons.
We added an extra negative charge.
Still only 17 protons, because if we change that, we wouldn't have chlorine anymore.
Protons don't move.
Right.
So chlorine now has a negative charge, and we write that with the symbol with a negative charge in the upper right-hand corner of the symbol. Chlorine minus 1. You don't have to write the 1. It's like math. 1x, x, same thing. Chlorine negative 1 or negative, same thing. So that's an anion. And calculating charge is going to... what do you say? We're going to do that for 9 months, you think?
Probably.
Probably 9 months.
Yeah.
So that's a good skill. You want to be able to do that one. These are the most common ones on the periodic table. These columns, only these columns, we should say, have charges set.
Yeah.
Because
basically,
they're families.
Yeah, each element in that particular column or family will have the same charge when it gains or loses an electron.
So write these down. Group number 1, write it right above your periodic table. That's our +1 column. Group 2 is our +2 column. Group 3, skipping all the transition metals, that's our +3 column.
Hey, I see a trend.
Well, but we're not going to continue that trend. Let's go backwards. Noble gases. Well, they're noble. That's a big 0. They don't form any. Halogens, -1. Oxygen, -2. And we will include, there's only 2 of them in there, nitrogen and phosphorus, but those are -3, because then we get into the metalloids and they do something else. -3 and phosphorus, -3. So write those charges down. Those are going to be incredibly important for the rest of the year. You'll use those numbers a lot. But that's another pattern based on how the ions form.
Hey, someone told me one time that group 4 could be plus or minus 4. Is that true?
No. It's actually, they do a different type of bonding. They're not even ionic. You might have heard covalent. They're more covalent bonds.
Okay, so we're going to ignore group 4.
We're going to ignore group 4.
Yeah.
So +1, +2, +3.
Excellent.
Skip. -3, -2, -1, 0.